Today we're going to go through a quick presentation of creating a 2D schematic, passing that schematic information via an XML file into Pro Cabling, where we can create accurate 3D wire lengths. From that we'll take that harness, flatten it out, and then finally put it in Pro Detail where we can document the flattened harness. Here we have Creo Schematics. I have a partial schematic created here. I'm going to go to our library and add a couple other components. The first component I'll add is a switch. This library can be stored either internally or it can be an external library using Creo Schematics Standard Edition. Another thing that we can do is when we place these particular components, there's actually information inside of them that will map them to a 3D part. As we can see here, I pick on the properties. It says the model name is push button. There will be a Pro Engineer part in our assembly called push button that represents this 2D symbol. That's how this mapping takes place. The same is true when I go in and create the wires. I'm going to go in and start creating a couple of runs right here. One of the things is while I'm creating these wires, I can also do this via map keys. I'm accessing the properties of these wires also from the library itself, just as we grab the connectors. Now that I have several wires routed, I'm going to take a look at the properties, just as we did with the connector, and we can see a lot of things aren't set. We can input a lot of properties just via an XML file. I'm just going here and saying let's just make this a, let's say a blue 16 gauge wire. By doing that, I've automatically now populated this wire, as we can see here, with all that information. So we can populate a lot of information into our symbols and into our wires very quickly, leveraging XML information. This is the information that gets passed into Pro Engineer. One of the nice things with this new user interface is I can customize it. So I can do the same thing with these other wires, but instead of me going through all those picks, I just use a map key to do that. I'll say that this is a red wire and that this one is going to be a yellow 14 gauge wire. So again, we can customize the interface to create a lot of geometry rather quickly. Once we've created a command or run through a command once, we can put that in a map key and play it just like in Pro Engineer. At this point, what I'm going to do is just create a real quick table and place that here. And this is the connectivity table. As we can see, the different components that we have, the from port, the to component, and the to port listed here. This is the information that we're going to send out to Pro Engineer. So I just say File. We'll export out an XML file. We'll call it to cabling. And we'll flavor the XML file for cabling. If we were sending it to piping, if we were doing hydraulics or pneumatics, we would just click the button for piping. We'll overwrite the existing XML file, and now we can go to Pro Cabling. Here's our assembly, no cables here. I'm going to go in and say let's go into cabling. First thing we want to do is import that XML file. Here it is, to cabling. I'll import that. We can take a look at what's in that file, and we can see the right side, this is all the XML information. The middle column is what exists in our 3D assembly. We haven't added anything yet, that's why it's blank, and that's why on the far left it says it's not matching. There's not a one-to-one correspondence between the 2D and the 3D information. The first thing we want to do is create a harness. That's just an empty part file. I'll just take a default here. Now that we have that, from now on, every wire that I create, every cable I create, will go into this empty part file. First thing I want to do is do auto designate. What that does is it automatically maps all the model names inside those 2D symbols, and it finds their corresponding 3D parts. We can see that. If we have duplicate parts, as we have here, it'll say which one is really the V connector number 1, which one is the V connector number 2. All I have to do is select one of those, and then it finds the other. Now that we have it designated, I'm just going to start routing our wires. I'm going to say let's route some wires. Let's find the ones in the XML file. I'll grab all the wires and we say OK. we can see that it runs all the wires to their connectors. But what we'd like them to do is go through the grommet here, this hole in the wall. So what would be best, I'm going to cancel out, is to create a path for those wires to follow. That's just called a network. It's a real simple thing to do. I just start picking points where I want my wires to go, and they'll follow that path. Here's a axis that's going through the center. I'm just going to say follow that axis, and then continue on to the other side. This is the path that our wires will follow. I'm going to go through the exact same picks that I did before. Let's grab all the wires. Let's route those. You notice that they do follow the path that I've sketched now. And now we have a completed harness. I'm going to take this and flatten it out. Just go into Harness Manufacturing. It's going to create an assembly for me. I'm going to first of all grab the one part that we created, which was called part 001. That's our harness. I want to flatten that out. Again, we'll just create an assembly because we're going to assemble all the connectors on the end. Here's our 3D harness. I'm just going to say let's flatten it out. I'm going to pick a point on it. They automatically fan it out. And in the window behind here, we can see the flattened out harness. I'm just going to say assemble all the components. And now all the components have been assembled onto our flattened out harness. My next step would be to create a drawing. As we can see, we have our 3D assembly here with our wires routed. I'm going to go in and say let's create a drawing to document that flattened harness. Again, that was that assembly that I created, so I'm going to say it's in session, assembly 001. And I'm going to put it on a template that already has a has some bills of materials in that. We'll turn off our coordinate systems. We'll change the scale of this. And then just center it a little bit better on a drawing. This is some of the information that we can pull out. Here's just a simple list of all the connectors and how many we have of each. Here's the reference designators, the 2D symbol names, and the 3D part names. The next one is each spool of wire and how much from each spool, so we have our different gauges of wire and how much we've used of each color. And then here's that connectivity list, the spool of wire, the individual wire name, its individual length, from conductor and pin to connector and pin. So all this information is updated as we change our assembly, as it changes through its life. All of these things will automatically update.